Hi there, I'd like to welcome you to the Revit Conceptual Massing Environment webinar. This is being presented by myself, Bill Allen, with Evolve Lab. We are a computational design and BIM consulting firm. A little bit about us and some of the services we offer. We offer computational design, i.e. visual programming, scripting, custom tools, content management, building all of your Revit families, templates, BIM implementation, BIM execution planning. Those types of services is what we offer. If you have any questions about that, please reach out to us. You can find us at evolvelab-inc.com. And that's a little bit about us and what we do. A little bit about me. I'm the co-founder of Evolve Lab, speak at a couple of events throughout the United States, i.e. Autodesk University, Central States, BIM workshops, and the computational design symposiums, things like that. I also want to mention to follow us on Twitter, like us on Facebook, subscribe to YouTube. There's a lot of great resources out there. We're constantly posting, and so it's another great way to access some of these resources through some of our social media feeds. So please check those out. Today we're going to be talking about the Autodesk Best Kept Secret, the Revit Conceptual Massing Environment. The reason I call this the Best Kept Secret is because most people in our industry have no idea it exists. If you ask someone, hey, do you know about the Revit Conceptual Massing Environment? General answer will be no. So today we're going to be exposing that. Let's go ahead and take a look at our learning objectives. Our learning objectives for today are to create a robust Revit mass with push-pull constraints, creating parametric relationships with the Revit conceptual mass, learning how adaptive components help model complex geometry in this environment, and finally creating real Revit systems with the Revit conceptual mass. So with that, let's go ahead and get started. What you're going to do is go ahead and open up your Revit software. Go ahead and click on New Conceptual Mass. The template will pop up. Go ahead and pick that, say open. And this is basically another family just similar to how a casework template family is, or door template. So we're starting with a Revit family template here. It's quite a bit different. There's going to be quite a few different features and the way you work with the Revit conceptual mass. So let's take a look at that. So immediately what you can do is in your ribbon you can already just start drawing like you do in, say, SketchUp or any other drawing program, and you just start kind of blocking out whatever form or footprint of that form is going to be. And so in here I'm just going to go ahead and create just a simple shape here, and I'm going to pick on this, and once you pick on it you can say create form. And it's going to basically extrude that form up. And so what we can do is we can start pushing and pulling the faces, not only the faces, but you can also push and pull the vertices on here. And then you can also grab the individual points and push and pull those as well. Just like that. Okay? So this is how you can start interacting with some of this conceptual geometry, just with pushing and pulling, very similar to, say, SketchUp or other massing programs. All right, so you also don't only have to work with solid forms, you can also work with void forms. So if I also want to just go ahead and make sure that you're drawing on the right face, you'll see how it highlights here. If I want to, say, create a negative right here, I can say void forms, and it'll actually push that geometry back. And again, it's just faces that we're able to push and pull. See that? So what I want to do is now, like, say I'm getting, somewhat content with this. This shape isn't very happy or sexy, but let's go and say, yeah, I'm going to use this one. You can start a new project. Okay, once we're in our project, let's just go to a floor plan. I'm going to close my hidden windows, and what I'm going to do is just Control Tab back into that mass, and then I'm going to load this into my project. Alright, once that's loaded in, I can go to my 3D view and begin hosting walls and roofs to this. And what you'll do is you'll go to Massing and Site and say wall by face, And you can see, like, even for these really obscure wall forms here, that it's still going to go ahead and host that wall to it. And then I can also use the curtain wall tool if I want to host a curtain wall. So you can get some of that. And I should also be able to do a roof by face here. Create roof. And so now I'm starting to actually create roofs, walls, and curtain walls, you can see, from the mass, which is pretty cool, I think, because you're kind of mitigating that data drop within here. So the other thing, let's say that your designer's designing in Revit, the conceptual mass, you're going to hear hosting walls, and then they go ahead and update the design, as it always happens. So you don't have to lose that information. I'm going to just kind of simulate how that would work. So let's say that maybe programmatically, they needed a little more square feet, so they're pushing this out a little bit, and maybe they want to add, maybe they don't like this move here, so we're gonna pull this down a little bit, and then we'll load that back into our project. No, I don't want to save that right now. And then it's going to prompt you, since it's loading a family in here just like it does from any other situation with the same name. You can say overwrite, and you'll see that the mass is actually going to update. You see the mass update, but my geometry isn't quite lined up here. What you can do is you can click on your geometry and you can say update to face, and click on this and say update to face. And over here, and you can see that this geometry, now I'm getting the option. I'm not totally having to remodel all of this. All I'm saying is, as long as that face is still there, it just updated. I can say update to face, and it's automatically basically recalibrating that face, that surface, to host to that same location, which is pretty cool. Alright, so that's how you can start creating real Revit systems from the conceptual mass. Create a new one, conceptual mass. Let's go ahead and look now. What I want to do is start thinking about the information associated to this mass. And so maybe starting to think about space program and gross square footages, things like that. And so we're going to start looking at how some of that can work. What I'm going to do is I'm going to extrude this up and also show you another technique here. You can grab your mass and you can say add edge, and you can actually start to grab these guys and with the little gizmos push and pull those as well. Or you can also say grab this and I'm gonna say add profile, and I can kind of add these little intermediate profiles through the mass. I'm gonna make this just a little bit taller, and then if I click on the mass and I say X-ray, you can see I'm starting to see my skeleton here as far as what is being extruded. So I'm going to move this up maybe just a tad. And what I can start doing with these is I can start rotating these a little bit. Let's say, maybe you want to rotate this one there. And you can see I'm starting to kind of get this form. Don't want that sticking out like that, though, let's say, because that's not going to be very happy. The builders are not going to be happy with me on that one. So let's see if we can't grab it and then rotate it where it sits. Grab this guy. And what I want to do, I bet it was when I pulled it. We'll want to pull it up like this. Use the little gizmos whenever you can, rather than trying to think you can pull it up. And then so if we rotate this guy a little bit and grab this one and rotate this guy a little bit, you can see how we're starting to kind of get these moves here. What I'm going to do is turn off the X-ray so you can kind of see that. And what you can start to do too is start to think about dividing the surface and starting to study, what type of patterning, whether it's a curtain wall system, or maybe you want to start thinking about a triangulated curtain wall system. So I'm just going to use there's a triangle. These are really good for making sure that your geometry is planar. Triangles are always really helpful with working some of that out. And I'm just going to do the same over here. Make sure you pick the face, say divide surface, and I'm going to pick that triangle again, and there we are. Now the other thing you can start doing is consider playing with the spacing a little bit too. So if I wanted more triangles, you can change those in the properties over here, and it updates like that. Okay. See that difference? This is getting pretty interesting geometry. And the interesting thing is, since we're building it with these triangles, these are actually helping with the planarity of it. So it's actually, even though it'd be harder to document, it is actually buildable with some of this geometry. All right, and so then what I'm going to do is I'm actually going to say, oh yeah, I'm pretty happy with that. I'm going to load that into my project. And what we're going to do now is we're going to start thinking about how we can start grabbing some of the gross square footages for this building. So once this loads in, I can start looking at my levels and seeing how that plays a part into the building. So I'm actually going to go to my floor plan to place this just to make sure I'm within my levels. Okay, so if I go to component, so you're going to place it just like you do at other families. You'll say component, pick here. Alright, and what I'm going to do is look at this in elevation. And I'm going to start offsetting some of these levels. Let's also, so I get a good idea, let's not crop it for right now. And I'm going to grab these and say copy, multiple. And you can array these too, but it's kind of hard to know how many floors you have here unless you know the exact height of your building. So I'll copy these up. Okay. And then what I'm going to do is in my 3D view, I'll grab this guy. And what I'm going to do is I'm going to mass floors. See, this comes active in the window right here. Mass floors. And what it's going to do is prompt you and say, well, which levels do you want to use to mass your floors? And I'm going to say all these. Now these exist because I just created them. This would have been a much shorter list if I hadn't done that. So it's important for the steps. Create your levels first, then click your mass, and then you can mass floors. You see that? And so now if let's go create a section box, and I pull this in a bit. You can see I have my floors and they're going right to the edge. It's a really nice way to create your floors without having to click every single one of them and go to the face. So this gives me the geometry, but we're actually already starting to create data from this, and that's what I want to show. Is now if we go to schedules and quantities, and we go to mass floors, let's say OK, and let's say level, and I want floor area. Let's say OK, and check this out. I'm starting to get my square footages for every one of those floors. And then if I want to go and say calculate totals, sorting and grouping, grand totals, and here you can actually start getting your total square footages for your building. This is gross square footages per floor, and then the overall gross. All right. Now again, what's pretty cool, and let's do this, close that guy, Close this guy. I don't know why my Revit is so dog slow today. Close this guy. Alright, let's take a look at our family. What I want to show is that if you come in here and let's start thinking about how we manipulate this. Maybe I want to, let's do X-ray, and maybe if I start pushing and pulling some of this. Okay, so my floor, the thing I want you to think about is that my floors are updating. So the mass is updating. It's updating the patterning on the triangle. So I'm just going to push these in a little bit. Maybe I want to start playing with some of those moves. Okay, doing that. And I'll load this now into the project. And what's nice about this is we're getting, we're going to say overwrite, we're getting this geometry is going to update in the Revit project environment, but not just that, not just the geometry, but then also the data is going to update. You see that, how the square footage is updated? So this is pretty key, so that way you can see if you're meeting your programmatic requirements for the gross square feet. Okay, pretty cool stuff. Alright, so I'm going to show another thing that I started playing with the other day. Gonna, just for simplicity, let's delete this guy and set to level 1. Draw reference plane. Okay. Draw that guy. We'll draw this guy. We'll put a dimension on here. And we'll put a dimension on here. Grab this dimension string, and what we'll do is we'll add a parameter. So you get this drop down, and I'm going to just call this width. Make that instance base, and I'm going to call this guy depth. Depth instance base. Okay. And what I want to show you is this is not how you want to do it. Okay. If you have, I can either, well, just show you this way. Draw these on top, it gives you the option to lock these, okay? And then if I create my form from this guy, grab it, say create form, and when I update this and I say, oh, actually I want you to be 60, notice that the whole face does not go along for the ride. See that? So that's not how you want to do it. What you want to do is actually, you can create your form, but you actually want to constrain the faces. So you want to line lock this to this reference plane like that. Align lock that face to that reference plane, that one to that one, and align lock this face to that reference plane. So now, if I change this to 60, you can see that the face goes along for the ride, which means it pulls the whole mass, which is what we want. All right. So what I want to start doing now is looking at how to drive this programmatically. Okay. So in here, what I'm going to do is I'm going to create a new parameter. New parameter, and say area. We'll make that instance base, and let's give it the correct category. It's an area parameter. Okay, and what I want to do is I'm going to say width equals area divided by depth. Okay, and we're going to say my area for my building has to be 25,000 square feet. Okay, and you'll see that the width is automatically updating. All right, so if I apply this here, ooh, it's going to get really long. Okay, there we are. So let's say, oh, those proportions are way out of whack. I'll actually, let's get this evened out a bit. Say 150. Okay, there we go. So you can see that it's retaining my programmatic square footage. I cannot override that. So if I want to say 125, it keeps that area in there and it updates the other distance. So in here, if I actually grab this, let's make sure I'm doing it right. Let's see, I need to be able to modify depth. So if I grab my depth and I start thinking about pushing and pulling this guy, it's going to update that width automatically, even in this environment, which is pretty cool. So that way we're always meeting our programmatic requirement right here of that 25,000 square feet gross. Cool? All right. All right, so that's how you can start maintaining that. I'm going to get out of this. The other thing I want to start looking at, delete that. All right, for this next part, I want to show how you can start creating these types of geometry and these types of moves. This is a project that we at Evolve Lab helped out another architecture firm with, helping with the facade design here. So I'm going to show you our little secret for how we did this. All right. So what we're going to do is we're going to go ahead and set the work plane to here. And you can see that if you show, you can see that it actually highlights that work plane, which is helpful. What I want to do is show you what you don't want to do. You don't want to use these model lines, and I'll show you why. So if you grab here, you're going to say model line, make sure 3D snapping's on, and we're going to create this type of movement. And what I'm going to do is reset my work plane to level 1, and I'm just going to copy these over and show you why you do not want to use the model lines. All right, let's say 30, sure. And 30, and 30. Okay, now the problem with this technique is that if you want to loft between these two profiles, notice my points went away. You see that? My points went away, and I can't grab that line. Now I might be able to, if I say X-ray, does it let me? It does. And I could say create form, it lets me do that. The problem though is the model lines are going to show up in your project, okay? Plus they're harder to pick. So what I'm going to do is I am going to get back here and show you how if you did draw it with model lines, you can actually, you're okay, don't redraw all your geometry. All you have to do is pick this and say is a reference line, and it automatically shows up correctly as a reference line. The other key thing here is that if I say create form, notice it retains the points, and I can push and pull these points. See that? And the other key piece is I can grab this guy and say create form without having to go into the X-ray mode. Plus again, these guys don't show up in my project, so that's important. Okay, and I'm going to show you how you can kind of get some different moves depending on the order in which you loft. So here I kind of pick these individually, and I want to show that if I kind of push and pull this guy, that it's doing it very segmented-ish. Okay, so if I do that, it's very straight. Okay, maybe that's what you want. Maybe you like straight moves. That's all right. But say you want something more curvy, and you're not happy with kind of these straight moves. Okay, get back to where we were. Moving on back. Go back. Go back. Okay, so what I'm going to do is instead of picking these individually, I'm actually going to pick all of them together, holding the control button, and I'll say create form. And now what I want you to notice is that you get these swoopy movements when I push and pull my little gizmo. Look at that. Oh, that's a little better. I like some of these moves. So these are a little more swoopy movements, right? Okay, see that? So that's how you can get some more swoopy movements. And maybe I want to push this guy back a bit. Starting to look at that, right? Well, let's take a look at now. You know, this is going to basically become our rig. So I'm going to go ahead and say divide. And I am going to set this guy to 1, maybe this guy to 24. And what I'm going to do is I'm going to host my adaptive component now to these lines here that are now visible. And what I want to do, this next part is the most important step. If you remember nothing else, remember this, because this will not work unless you do this step. And it's very discrete, so it's important that you pay attention. Paying attention? Okay, here we go. So you pick on your surface, and right here, this very discrete little piece in your ribbon, surface representation, this little tiny arrow, pick on that and say nodes. You see this? I start getting these dots that come across, and these are going to become the points in which I host my adaptive component to. So I'm going to do that, get my points for that, surface, and then I'm going to do this last one, nodes. Very, very important step. Okay? Now what I want to do is create an adaptive component that I'm going to host to these points. And notice that it's a pick, 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 pick. So there's 4 points that I need to create with my adaptive component. So I'm going to go new, family, and I'm going to go to the generic model adaptive family. I'm going to open that guy up, and then I'm going to set this as my work plane. Again, you can say show just so you can see that, and I'm going to draw very similar to what I drew over there, and I'm going to make sure that it is a reference line and 3D snapping is on, and I'll pick, 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 pick. And what I can do is I can pick on these points, and what I want to do is tell these guys to become adaptive. And what that's going to allow me to do is to make movements in that massing environment that these points are going to follow. So I'll say make adaptive, boom, 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 boom. There's 1, 2, 3, 4 clicks, right? So what you can do is you can host a profile on here. Oh, what I want to do is make sure I set my work plane to this surface, this face, this surface. Set work plane to here. There we go. Look at that. So we're going to pick here, here, here. Let's do it like a 6x12. And I'll say create form. Get this glorious framing member here, and what's nice about this is you can push and pull this guy. You see how the geometry goes along for the ride? That's what we want. Okay, so I'm going to load this in to my family. It's always good to name these, by the way, which I'm not doing right now for the sake of time. Don't be like Bill. Name your families. So see, I load this in, click, 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 and click. And I'm going to do one more, click, click. It's thinking a little bit about it. There and there. Okay. And what I can do, they introduced this amazing command called the repeat and divide. And so what you can do, before 2013 you had to click every single one of these points, but what this does is you click here, and the program assumes that you want to go ahead and complete all of these. And I got one extra one in here probably from when I started this. That's okay, I'll delete this guy. Okay. So that's how you can start actually hosting this type of geometry onto here. And you can see that if I grab this and I push and pull it, that my adaptive components go along for the ride. I think the key part here to think about is that we're actually able to do this without any kind of dynamo, any kind of grasshopper, computational, and it has that look that you often see associated with computational design, this very progressive, very sculptural form of geometry, and it looks and is complex, but it was very easy to build without using any kind of scripting. And you can use scripting, and I have used scripting. Those are valid tools and you can totally use them, but you don't have to. So if you're intimidated by that, you can use this process right here, and it works very well. Okay. The other thing I want to start doing is looking at the divide surface custom patterns. So let's go ahead and take a look at those. I'm going to do, I'm not going to save right now. Create form again. You guys are going to be really good at this creating form button. Alright, come on, get up a little taller. I'll make this a little wider. And I'm just gonna start showing you how you can start creating custom divisions. Alright, so here I'm gonna create a void just so we get something else going on, some movement. Go ahead and accept that. And again, you can just move these faces. I don't want that guy. Move this guy back. Okay. All right, so let's look at creating custom pattern-based surfaces, families, and applying those to surfaces. So here I'm going to divide this surface, just like before, you can see. But what you can do is you can actually create different types of patterns rather than just rectangle or triangles. Let's say maybe I want to look at the hexagon pattern. Okay. And let's say that's like way too big. I want something more like this. And I want to note too, you can do either fixed number or fixed distance, maximum spacing, minimum spacing. Okay, but just for today, we're going to use the numbers. Okay, those moves are starting to look a little better for kind of a surface here. And what I want to point out is that you don't have to just use this. This is just kind of a concept to start getting the proportions right. If you want to create your own pattern, you can go new family or new component, new family, and then say generic model pattern based. Okay. And we're going to start a new family here. And within this, we can click on here and say use the hexagon, okay, because that's what we were looking at. And if I want to start thinking about, you know, solid and negative movements, what I'm going to do is I'm going to set my work plane here, and I'm going to build me a little frame. Okay, so let's do, I'm going to say 12 by 6. And what I want to do is do, say, 6, 6. But I'm going to center this, so I'll grab this line here, not that line, this line, and say 12 inches. And grab that. Profile, grab the frame around and say create form. And it'll loft that form around the frame. Okay? Now if I load this into my family, okay, I can grab this surface and swap it out for my new one. There it is under the hexagon. And it retains the divisions, and it can also start assigning more geometric form to that. You see, it's not just a flat 2D division. This is my frame that I actually started to build. You can do all kinds of things. You can put a solid surface in here, start develop perforations. If I update this, it updates the divisions on the face here. So this is another really fast way to start studying, you know, patterns, the faces of the building, without using any kind of parametric modeling, any kind of visual programming. Just very simple, easy patterning in the Revit Conceptual Mass environment. Okay, we're working hard at providing solutions for you, whether it's computational design or BIM efforts. Please reach out to us. You can find us at evolvelab-inc.com. Thank you very, very much for this presentation. Please remember to subscribe to us so that way you can get the updates from us as well as on Twitter and Facebook. That will help you out greatly. Share us with your office, and we look forward to chatting with you.